Welcome to a new episode of my GNU/Linux and USB tutorials. Today I want to show you how to write to USB out endpoints type bulk transfer from a Linux driver. So the goal for today is I want to write the GPIO chip compatible driver for my Atmega32U4 microcontroller so I can control these LEDs here by using the GPIO tool GPIO set. So first let's take a look at my USB devices, and you can see here this is my Atmega32U4 USB device, and when I take a look at its endpoints, I see this device has one endpoint from the type bulk transfer and the direction is out, and the size of the endpoints is 8 bytes, and over these 8 bytes I can control 8 GPIO pins of my Atmega32U4 microcontroller. And the way I can control them is each byte stands for one GPIO pin, and here bit 0 means if it's set to 0, don't change the output value of the GPIO pin, and if it's set to 1, change the output value of the GPIO pin to the value which is written in bit 1. And here in bit 1 we can set the value. So that's how to use and how to control the GPIO pins over this endpoint. Now let's implement the GPIO chip compatible Linux driver for it. Therefore let me cd into my USB tutorials folder, and here I have a folder for the kernel drivers. So I already have a Linux driver for a simple USB hello world program, and I have a Linux driver for control messages. So let me copy the hello world driver and create a new folder I will call free bulk out message here, and let me change into this. So what we have in here is we have the source file for our Linux driver and a makefile to build it. And if we open up the source file, we can see this is just a simple hello world Linux USB driver. And now I want to add a GPIO chip compatible driver here. So in this video I will just copy paste it from an existing Linux driver I will use for a template, but if you're interested in how to write the GPIO chip driver in more details, I have already made a video on my Linux PCI driver series, and I will also add a video someday in my Linux driver tutorials. But for now I will put only the link to the existing video in the description. So as I need a GPIO driver, I have to include linux/gpio/driver.h, and then I will go to the official Linux kernel GitHub repository, and here I have a driver for a GPIO expander from Texas Instruments, which also supports 8 output pins. And I will just copy some of the source code and use it for my video, or for this driver here. So let me paste them in here. And then I will rename the functions. Now they are called tpic2810, and I will replace tpic2810 with M32U4 expander. Okay, this is done. And here in this, so what we basically have here, we have declared a lot of callback functions. So for example, if we want to set the direction of a GPIO pin, these two functions are called, or this one is called for getting the direction, and these functions are called to set one GPIO pin or to set multiple GPIO pins. This device supports up to 8 GPIO pins. Yeah, so it's pretty the same as in our device. Okay, and down here I have a struct with all the data for our GPIO expander. So here I have a struct from the type GPIO chip, and I need a pointer to our USB device, and I will call it USB device here. Okay, so this is the function in which we will set the GPIOs. Let me just remove these 11 lines here but before we are looking at this function, let's add the GPIO chip in the probe function. So I will go down here to the probe function. First I need to add some variables, so I need a status variable, and I need a variable from the type M32U4 expander, and I will call it GPIO. So the first thing I will do is I will allocate memory for my M32U4 expander struct. So I will set GPIO to def mem kzalloc, and def m is a managed function for allocating memory, and I want to bind this memory to the lifetime of my interface here. Then I need the size of bytes I want to allocate, and I need the flag or the type of the memory allocation. Here I will use GFB kernel, which is about the default. And in case I got a 0 pointer here, I will return error no memory here, because if this allocation doesn't work, we're out of memory. Okay, now after the allocation worked fine, I will set the chip field of my GPIO expander to template chip, which is this struct up here. And then I will set the pointer to our USB device to interface to USB device. And I have to pass it my interface here from the probe function. Okay, then I will set the interface data, because in the remove or in the disconnect function I need to remove the GPIO chip. So let me use USB set interface data. So I want to set my interface data to this GPIO expander struct here. And then last but not least, I have to add this GPIO chip with the function GPIO chip add data. I want to add this to chip, and I want to add my GPIO struct here. And in case this returns something which is smaller than 0, an error occurred, so I will do a print here. Error adding GPIO chip, and I will return the status here. Okay, so much for the probe function. Now let's go down to the disconnect function. So here I need my GPIO expander struct 2, and now I will call the function USB get interface data to get back the data stored in my interface. And then I can call the function GPIO chip remove to remove my GPIO chip, so it will disappear on the system. Okay, so much for adding the GPIO device. Now let's see how we can control the GPIO pins, and let's implement the bulk out transfer function. So here I'm creating a pointer from the type of my GPIO expander struct, and I use GPIO get data to get the data from the GPIO chip, which was passed in the function here. Then I need a pointer from the type unsigned int 8-bit in size, and I need a status variable, a transferred variable, and an iteration variable I will call I. So what are the 3 arguments up here? So this one is a pointer to our GPIO chip. In this mask value we have the bits, or the bits are set which we want to change. For example, if we want to change bit GPIO pin 0 and 1, everything would be set to 0 except bit 0 and bit 1. And in the bits variable, we can find the bits or the value of the bits we should set. So for example, if we want to set GPIO 0 and GPIO 1, the value would be, the mask would be this. And now let's say we want to set GPIO 1 to 1 and GPIO 0 to 0, then the bits would be this here. So this is how the mask and the bits fields work. And what we have to do now is we have to allocate memory for the memory we want to write to the USB device. So I want to allocate 8 bytes and the flag is GFP kernel here. And in case this returns a null pointer, I will return from this function. Okay, and now I will start a for loop. In this for loop I will check if bit I in the mask is set, because if so, I will set data I to 1, and in case bits and the ith bit is set in this bit array, I will OR data I with 2, and this way I'm setting the GPIO pin. Okay, and then I can do the USB bulk message. So therefore I will use the function USB bulk message. The first argument here is the pointer to our USB device. The second argument is the send pipeline, or the pipeline we want to use to send it. And here I will use USB send bulk pipe GPIO USB device, and the endpoint number is 1 here. The next argument is the data we want to write, and here it's important that this pointer or this data here is dynamically allocated with kalloc, for example. If we would have defined a static array and passed it in here, this function will not work. So please make sure to only pass dynamically allocated data here. The next argument is the number of bytes we want to transfer. This is 8. Then the next argument is a pointer to an integer variable, and in this variable we can store how many bytes have actually been transferred. And the last argument is a timeout in milliseconds. I will set it to 100. And then I will print out to the kernel's log. And, my USB dev driver. I will print out the status here, and I will print out the number of transferred bytes here. Status and transferred. Okay, cool. And we have dynamically allocated memory, so we have to free it at the end. So let me free the data array here. And that should be about it. So now let me try to compile this program. Okay, this looks good. And now let's take a look at how much GPIO chips are available on my system here. So currently we have 1 GPIO chip already available on my system. And now let me insert this driver here. And now if I run this command again, we can see we have a second GPIO chip available here. And if I use GPIO detect, we can see here this pin here. This is the name we have passed, and it offers us 8 GPIO pins. Okay, and now all I have to do is I have to use GPIO set, and then I can modify and set the GPIO pins. So I want to change pins of GPIO chip 1, and let's say I want to set GPIO 0 to 1 and GPIO 2 to 1. Yeah, you can see the lights went on. And now let's turn 1 back off again. So you see this is working. Okay, cool. So we have successfully written a GPIO chip compatible driver to control the GPIOs connected to my Atmega32U4 USB device. And we have also learned how to write to a bulk transfer USB endpoint. So I think that's good for today. So I hope you've enjoyed the video and learned something. If you want to support my work, you can buy my coffee on buymeacoffee.com/Johannes for Linux. So that's it for today. Thanks for watching and goodbye.